What up, people? I'm sure you all know about attendance lists. Hashtag never been there but still on the list. To-do lists, shopping lists, and so on and so on. But do you know about lists in computer science? No? Good. That's about to change right now. Have fun! Alright, a list is a kind of dynamic data structure. You already know that much. That means we should have no problems adding elements to the list, dynamically adjusting the memory requirements. A list is made up of individual nodes. These nodes in turn are made up of data, so some kind of content and a pointer. Normally, the pointer points to the next element in the list. The elements in a list are connected like the links of a chain, which is why these lists are often referred to as linked lists. There are actually a few different types of these lists: the singly linked list, the doubly linked list, the circular linked list, and so on. For now, we'll deal with the singly linked list. A singly linked list can be empty or it can be made up of various elements with pointers pointing to additional elements. But in a bit more detail, a singly linked list should have the following elements: an anchor, one or more nodes, and a null terminator. Huh? What are you blabbering on about? Hey man, don't worry, I'm about to show you. So how can I describe these things? Okay, so you're at the movies with your friends and you've reserved the whole row. The first person in the row is the start pointer, and the one at the end is the null, the 0. Now between these two, we've got a bunch of nodes. Each of your friends points to the person in the next seat. That means each node knows the one who directly comes next. Except for the 0, who doesn't know anybody. He's the end of the chain. Got it? No? Okay, let's try this again. The first element in a list is called the start pointer, or you could call it the anchor if you want. The anchor points to the first node in the list. This node is also called the head of the list. If this element is the only one in the list, then the head points to the null element. The null element represents the end of the list. In larger lists, the last node just always points to null. One important thing to remember here is that in a linked list, each node only knows the node that comes immediately after it. That means node 1 knows all about node 2, but it doesn't know jack about node 3. So far so good. One great thing about a list is that you don't need to know its size ahead of time. A list can start off empty, and then you can fill it up with elements or nodes, as many and as often as you want. A list can handle the following operations: insert new elements, delete elements, search for elements. We'd better go ahead and check out how each of these works. There are 3 ways to insert elements: insert it at the beginning of the list, insert it at the end of the list, or insert it anywhere else at any given spot in the list. In principle, it all works the same though. Let's assume we have a list with a head and 2 nodes. Now we want to insert a node right after the head, so we go ahead and put together a new node. Now the node points to the first node in the original list. Now since we know that every node has one node that comes after it, we can redirect the pointer in the head node. Now it points to the new node. This works the same way when you insert a node at a given spot. First you create a node, which then points to the following element. And then the pointer of the previous element now points to the new node. And bam! The new node is inserted in the list. But watch out, make sure you determine which node comes after the new one before you redirect the pointer to the new node. Deleting stuff is also super easy. So now we have our list and we want to delete the new node. First, we're going to change the pointer at node 1 so it's pointing at node 2 again. And then we can go ahead and get rid of the new node. Pretty quick, huh? If you want to find an element in the list, you've got to go from element to element till you find the one you're looking for, or hit the null element. Since each element is only aware of the one right after it, it takes a bit longer to search through the list. Nice! So in addition to the singly linked list, there are other types. You already know about the doubly linked list. In a doubly linked list, each element has 2 pointers. One pointer points to the element that comes after it, and the other points to the one that comes before it. If there is no next node, the pointer points to null. And if there's no previous node, the element also points to null. Another form of linked list is the circular linked list. In a circular linked list, the last element points back to the first one and not to the null element. Well, so much for that. So what have you learned today? A list is a dynamic data structure. A list element, also called a node, consists of data and a pointer. A list can be empty or not. In a singly linked list, each node only knows the one that comes right after it. You can add or insert new elements into the list, delete elements, or you can search for them. In addition to the singly linked list, there are also other types of lists, like doubly linked lists. An element in a doubly linked list has 2 pointers. one pointing to the previous element and one pointing to the next one. Or there's the circular linked list, where the end of the list points back to the beginning. And that's a wrap. If you're still in the mood for more, go ahead and give simpleclub.de a look. Have fun and see you soon. Adios.